Okay, we're given a polynomial, and we are asked to find a table of the possible quantity of roots of this polynomial equation when we take the polynomial and we set it equal to 0. But we're not going to solve it. We're just going to come up with this table of the possible quantity of different types of roots. So let's do step 1. Step 1, and we're following note that we saw previously. Step 1 says the degree is equal to 6. Now that's because the highest power on the polynomial is 6. So that implies that we are going to have a total of 6 complex roots, including multiplicity. Roots including multiplicity. It's good to mention that. Okay, so let's go to step 2. Step 2 says, well, here's where we address the number of variations in the polynomial. The number of variations in p of x. Well, p of x is equal to 3x to the 6th plus 4x to the 5th plus 3x cubed minus x minus 3. Now we begin with a positive 3 coefficient. So as we move on, we're still positive. We have no change yet, another positive, and boom, right there is our first change. That's number 1, change of signs. Then we go to the next coefficient, and that guy doesn't change. It's still negative. So we have only one variation in sign. One variation. It only changed signs once. All right, so let's move on to step 3. But before we move on, we want to conclude something. If there's only one variation in signs, we don't have a lot of options as far as the possibility of the quantity of positive real zeros. There's going to be exactly one. So let's say that there is going to be exactly one what? One positive real zero. So that's part of our answer. It's going to appear on our table. I'll go ahead and box it because it is part of the information we're going to use to construct the table.